All right, so maybe we can stay on track here. I'm having a lot of trouble with Zoom, but maybe I can share just the slides and we can at least move ahead here. The Kahoots seem to be impossible today. And I don't know if these slides are going to freeze up too, but we'll see. All right, so we'll talk about setting up your Android environment. All right, so this is part one, and there's more parts coming later of this. But so you have to make an Android environment, which we've already talked about. Now you can do it with Android Studio. Android Studio is the equivalent of Microsoft Visual Studio. You can download this big heavy thing, several gigabytes, and then you can build Android applications, and it has a little emulator inside there. So you can view what your application is going to look like, but we don't need to do all that. First couple times I taught this class, we used the whole Android Studio, but we don't need it. You can also install just the command line tools, but what we're going to do is just install a couple essential tools inside Kali Linux and use that. Turned out that most of this stuff was not necessary. Now, Android runs essentially Linux, and it runs best on a Mac or Linux host, the emulators we're going to use. Running on a Windows is difficult, but BlueStacks helps. Don't try to run Android Studio on top of Kali Linux. We're just going to use Kali Linux to be the source of the tools, and you could use any other operating system instead of Kali Linux, but Kali Linux is a good thing to use. So the main tool you want is ADB, Android Debug Bridge. Android Debug Bridge is a feature you turn on the phone, on your Android device. You turn on USB debugging, and then you can control the operating system from another machine through this tool, Android Debug Bridge. And you can push apps onto the device, you can pull apps off the device, you can get a command shell and use the device, read the logs, and many other things. So you can monitor running processes. You can, and you talked about Genymotion before, there's tons of different versions of Android available, and you can emulate them all. And the idea is so you can test your apps on these various simulated devices. The emulators, however, are not actually running the same version of Android that's going to be running on a real phone, because for one thing, they're running an x86 instead of an ARM processor, which is what phones almost always have. And they have root access. It's basically a rooted phone. And they don't have a lot of the things you need, like Wi-Fi and Bluetooth and such. So professional app developers usually have a bunch of real Android devices to test their apps as well. And if you want to analyze Android malware, you have to have real devices, because the Android malware detects when it's in emulators. But you can do a lot of the security tests that you need to do in Android emulators, and that's how we're going to do it. Now, the first time I taught this course, we installed VirtualBox, and then we installed Android on it, and it didn't run very well at all. So it's better to get a specialized Android emulator software. And there are a bunch of them that run on Windows, and the main reason they exist is so you can play Android games on Windows. But anyway, Genymotion is the best on the Mac and Linux, and Genymotion claims to run on Windows now, so it might work and it might not work very well, which has been what happened in the past. Anyway, so Android is a modified Linux kernel, and it runs a virtual machine that runs Java apps. You've had luck with Genymotion on Windows, Seth? Good, good. Well, if you can use it, it's by far the best. Did you get it connected to ADB yet? Because that's going to be the hard part. But see if that works. Anyway, so all right. Now on Linux, like Windows, you log in and then you launch apps, and all the apps run at the same privileges. So if you have Ubuntu Linux running and you're running several apps, if you look at Process Monitor, it'll show you they're all running as students. I have one user that's logged in, and everything I launch runs with my privileges. Yeah, someone says something works only on Win 10. You talking about Genymotion running on Win 10? No, Genymotion runs primarily on the Mac, but it also runs on Linux and apparently also in Windows. Oh, I don't know what versions of Windows. I would assume you have to have Windows 10, but I don't really know. Anyway, so on Android, it is very different. Each app runs with a separate user account. Every time you install a new app, it creates a new user account. And this is the Android security model. Now, a developer can develop a whole suite of apps, and they could assign them to all run as the same identity so they can share each other's data, but that's not the usual case. You can get a shell on an Android device with ADB shell, and I was going to demonstrate this tonight, but I'm going to not go off the slides until later because we're having such trouble with Zoom. But anyway, if I run PS minus capital A, that will show you all the processes running on the device. And here you see it's running a Delhaize shopping app from a grocery store and some other tools. And see, each one has a U0, U0A105, U0A7. These are the many user accounts. Every time you install a new app, it creates a new user account with the next number up. And so that's the Android security model. Someone says Kahoot screen is shared. Well, that's not good. But I think most people are still seeing the slides. The slides are on my webpage too, which may help some. Yeah, a lot of people see slides, but I wouldn't be surprised if some people are seeing, yeah, okay, good. Most people seem to be seeing the right thing. Okay, anyway, so when you get on your Android device, you can explore the file system with simple command line commands like ls and cd. And if you look at the data directory, this is where apps live. In data/data, there's a separate folder for each app. So here's that Delhaize shopping app, and here's other apps like an Amazon app. Each one of them has its own folder. The name of the folder is the URL of the company that made the app backwards. So delhaize.be because it's Belgian, and something smallbusinessmarketing.com. And each is owned by a different user. See U0, A52, A57, and that's the security model. The process of that app when it runs can only see things owned by that owner. So the apps are isolated from each other the same way users are isolated from each other on a multi-user operating system. So when you install an app, it comes as a single file. It's an APK file, which is just a zip archive. And inside there is several folders containing a bunch of files, and that's the app. That's why you can go to like APK websites and just download APK files. You can install apps without them coming from the official Google Play Store on Android phones. How to get command line on Android tablet? You can do that by using ADB shell. That's why you got to get your Kali Linux machine connected to your Android phone so you can do it. So there's a APK packaging process uses several pieces here, but you have these XML resource files, which are something modified. They're essentially a text file, but they're somehow modified to be unreadable in a binary form. And then you have some files that get converted to Java and class files for Java. And if you know Java development, you probably understand these things better than I do, but we'll play with it a little bit. APK Builder combines all these things into an APK file, and then you have to sign it. Now, here's where you get sort of the madness of the Android security model. Every app has to be signed. Now, signed code is generally a good thing. The problem is this code is all self-signed. It's not signed with a certificate you buy from a certificate authority that's actually verified anywhere. It's self-signed. So the signature does not prove anything. And we're going to do things like download the Bank of America app, modify it, and re-sign it, and it still runs. The only reason why the signature matters is you sign it, and then if you put an update to the app, it has to have the same signature. So the signature does not prove that that app really came from any trusted entity like the Bank of America or Google or anything. All that signature proves is that it might match a previous signature, and that would work for an update. So if I make a modified version of the Bank of America app and I email it to somebody and they try to update the real Bank of America app to mine, it will warn them. You can't do this. This has a different signature. I would have to convince them to uninstall the old app and install mine fresh, and then it would go on. So that's the only thing signatures do, is mean that you can have apps from the same developer that are recognized as also being from the same developer again later, which is why all signatures are supposed to have an expiration date of 25 years. Because if your signature expired, people would not be able to update their apps anymore. So anyway, you've got a variety of folders here used. The Android manifest file is the file that includes the permissions of the app. and a good place to start looking. And then there's various folders full of other things. So these are any files the developer wants to include in the assets, layouts and images and such. In the resource folder, libraries here. And if you have a multi-platform app that is compiled for different platforms, you might have subdirectories here for x86, ARM, and MIPS. Not every phone is ARM, but most of them are. And in the meta-inf is where you'll find the certificate, the RSA certificate to sign the app. And the Android manifest gives you a lot of information about the app. You can translate it into readable text with APK tool, which is what we're going to do. And when you install an app, it's going to ask you, this app wants to access the microphone and the network and access your pictures, and is that okay? And all those permissions are recorded here. So access network, access courts location, access find location. In this manifest is where little XML lines record the permissions of the app. All right, so you've got strings in the resources, and in classes.dex, you have executable file containing this stuff called Dalvik bytecode, which we're going to spend a lot of time looking at in this class. Now, when you install packages, if you get them from Google Play, it comes through this gtalk service, and that maintains a connection to Google, and that is not only real SSL, which means real authenticated certificates, it's pinned SSL. So the app even has a record of what the correct certificate should be. So even if somebody like a nation state like China were to man in the middle you and then send you a fake Google app that came from a real certificate authority, it still wouldn't fool this service, which is why this is very secure. And it also is why students can't really do this class very well from inside China, because you really can't get to Google Play from inside China. There are alternative app stores, and this is why you'll see a whole malware campaigns that target people in Asia, because they can't get to the real Google Play Store. And so they use these third-party stores. And for Amazon Kindles, which are Android devices, they have the Amazon App Store, which contains apps that are extremely far out of date, last I checked. Anyway, so you can install apps with ADB, you can open a command shell with shell, you can push a file onto the device or pull a file from the device, view the log, or forward TCP ports. And we'll use a few of these commands to do what we're doing to get copies of apps and analyze them. Now, typically, a Android phone is not intended to be a development environment. It's intended to be an environment to play an app on, to use an app. So they don't include a lot of the command line tools that you might want. So on Genymotion, they pre-installed BusyBox, and anybody that wants to start hacking phones, they put BusyBox on pretty early. That gives you a lot of the familiar command line commands you need to get anything done. And so here's what you do have on an Android tool. You have the package manager. You can list all the packages on the phone. You can execute the path command to find where the path is. You can install and uninstall apps, and we'll use a few of these PM commands to get apps off phones. You can view the system logs, and you can view information about the system with a couple more commands here. And we'll do a few projects on Drozer. It figures pretty prominently in your textbook, but I'm not pushing it too hard because it didn't turn out to be as useful as I hoped it would be. Drozer is intended to be like Metasploit for phones. It lets you run an agent on the phone, and then you can try attacking one app from another app, which sounds pretty awesome, but I haven't found any apps that really have this vulnerability in practice. So there's an app running on the device, and that's a remote administration tool. And then you have a server, which you run the Drozer server on another device. And so now on the phone, you run this Drozer agent and start it. And now it tells you the embedded server is on and listening on a port. And then you connect from the client here. And now you can get the app running on the phone to send signals to other apps on the phone, which is something, it's a potential attack method where you would trick someone into installing a malicious app, and then you would use that app to attack the other apps. In principle, it could work. In practice, I don't find these vulnerabilities to be very common. So binder is the process that lets one app talk to another. And so here's a thing to know about apps. This helps organize apps, and it should organize your thinking about them. There are 4 components to apps. Activities are the visual screens. You might have a login screen and then a profile screen and whatever your app does. Services are components with no graphical environment at all. Something that runs, that provides some functionality in the app, but does not lead to anything the user can see. Broadcast receivers listen to signals from outside the app. So if your app has the ability to receive an SMS message, it listens with a broadcast receiver, or if it listens for some kind of signal from another app on the phone. And then there are databases, content providers, that can store some kind of data. So we'll talk more about these later. One of the important vulnerabilities on Android is earlier versions of Android suffered from the content providers all being public by default. But that's been fixed for quite a few versions of Android now. So you can view the running services on an Android phone, and you'll see what's running here. It's running the keyboard and Facebook research and so on, running various processes. You can see how busy your phone is and how much of its resources are being used. And we've already looked at an Android manifest. If you download it and put it in a prettier text editor, it can colorize it for you. And you'll see all the components. So here, it shows the intent filters, which are the things it's listening for, intents from other apps. And here's icons and themes and such. Gives you general information about the context of the app. If you want to send a message from one app to another, this is done with intents. That's what they're called. And an intent sends a little package of data to another app. So here is the code that creates an intent. It's now going to send an intent that consists of just a URL for Google. Now, this intent does not specify what app that will go to. It goes to any app that is listening for URL. And if there's more than one app that's listening for URL, then your phone might pop up a box saying, which one of these apps would you like to use to open this URL? So that's called an implicit intent. It doesn't say what target to use. It just gives a URL which has a schema at the start, HTTP:. That is used to determine what type of data it is, and then any app that can handle it is eligible to receive it. Now you can have an intent filter. This is what you'd see at the other end. You're listening for this. Anything that starts with a scheme of HTTP, this app is now able to handle it. It can execute the view activity on this scheme. So it should pop up as one of the options to handle an HTTP request. And here's an explicit intent that will send it to exactly this one, COM Android browser, which is the default browser that comes with the operating system. And so you can more specifically target it. So here's what happens when you run an app. When the operating system boots, it launches a Java virtual machine, and then this zygote process, and each app after that causes a fork. So you end up with a separate process for every app, a separate copy of the Java virtual machine. All right, now that's the slides, which is good. I'm going to stop this one and process it. And what I'm going to